So can you all hear me? সবাই শুনতে পাচ্ছেন?
Yes, sir.
Yes, sir.
Assalamu alaikum, sir.
Walaikum salam. So we are going to start our class. As you know that in the last class we were discussing about the functional forms of regression, several types of regression function or regression model we can develop to assess the statistical significance of the economic variables. And we have seen one of the model, which was log linear model. In log linear model, both the dependent and independent or explanatory variables are found in the log form. And that actually measures the constant elasticity between the dependent and independent variables or explanatory variables. And today we are going to start our discussion from another model. There are a number of models. There are a number of forms of the regression models to assess the economic variables. So the second one that we are going to start our discussion on today is semi-log model. So first of all, I'm sharing my screen. Can you all see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So the semi-log model, actually this model has been used to measure the growth rate of some economic variables. Say sometimes we'll have to measure the GDP growth, GNP growth, or money supply growth, or consumer credit growth. Several economic variables should have been estimated to measure their growth rate. So when we are measuring the growth rate on some economic variables from one time to another time, from 1 year to another year, then we may use some regression model, which is known as semi-log model, or also known as growth model, because models like regression model like semi-log model, which has been used to measure the growth rate of the economic variable from 1 year to another year. These models are also known as growth model. Okay, and another name of the model is semi-log model. The reason of naming it log model is because here both of the dependent and independent variable are not found in the log form. Only the dependent variable would be found in the log form. Only the dependent variable. That means the dependent variable would be that variable which is your economic variables for which you are calculating the growth rate. Okay. For example, if you are going to calculate the growth rate of the population of a country from 1 year to another year, then the dependent variable is the population, log of population, because the value of population is very high or is very huge in volume. And to have a small volume, so we have to use a log form in front of the population value, because you know that for any mathematical value which is very larger, we have to use the log form of that mathematical value, so that the value has become a little bit smaller compared to your other variable value. When we are using this semi-log model or growth model, semi-log or growth model, this is the second model we are talking about. The first one was log linear model. So only in the semi-log model, only the dependent variable y will be in the log form. Y will be in the log form, but x will be in the absolute form. Okay. So when between dependent and independent variable, only the dependent variable y would be in the log form or ln form, then the model is said to be a semi-log model, because only one variable is log here. So as I'm giving an example to you that how the semi-log model has been introduced to measure the growth rate of any economic variable. For example, in a semi-log model, say it is written as y of t, which is equal to y of current year into 1 plus r. R is the growth rate, or also known as compound rate. Considering the compound growth rate, if we are measuring the growth rate using the compound growth rate, then 1 plus r is our compound rate of growth, which have an exponent of t. Okay, t is the exponent. of time. So here, y is the dependent variable. Say it is, let y is your population, t is your time or year, and yt is actually your population on, or population at the end of the year, population at the end of year, t is the time or year, y0 is the population at the beginning of the year. Okay, now you are going to estimate the value of r from this model, and when you are going to estimate the value of r, take ln in both sides. Ln means log in the both sides. After that, as you have the log which has been multiplied with these two factor or two elements, then we can take the two factors are in the multiplicative form, and if you multiply them, it would originate in the positive form or plus form. You can write down y ln of y0 plus ln of 1 plus r to the power t. Okay, and then t is the exponent which will come in front of the log. Now what you have to do is let ln of y0 is equal to beta 1 and ln of 1 plus r is equal to beta 2. So your model is now ln yt is equal to beta 1 plus 2 into t. Okay, this is your model. And if you have added the error term, then this would be your stochastic SRF or PRF.
Is PRF.
PRF. Okay, stochastic population regression function. What we actually do, we will estimate the value of beta 1 and beta 2 from this model using the OLS method or ordinary least square method as per the classical linear regression model assumption. So in that case, we will estimate it ln yt hat, and we will estimate b1 as a proxy of the beta 1, b2 as a proxy of the beta 2. Okay. So this would be our estimated regression function. Okay, this would be our estimated regression function, which will be estimated based on the sample. So when we have estimated this based on the sample, we will have to write down it like this: yt is equal to ln yt hat plus ei for the error term, which is the difference between your estimated regression value and the actual value of your y, or estimated value of the y and actual value of the y. So after that, I can write down the replacement of the estimated value of the regression function ln yt hat is equal to b1 plus b2t plus ei. And that is your stochastic what?
SRF.
Okay. Stochastic sample regression function. Now, how would you actually explain the coefficient, slope coefficient, that is beta 2 in a semi-log model? How do you explain the value of beta 2 in a semi-log model? So in a semi-log model, you can see from the model that the dependent variable has been appeared in the form of log, and the independent variable is the time, which is definitely year. Year would be in the absolute value, say 2001, 2002, 2003, 2004, right, like this. So this year will be appeared in the form of absolute value, and the dependent variable YT would be appeared in the log form. So when you are explaining the value of the value of B2, which is the slope coefficient in this stochastic sample regression function, the language of your explanation would be followed by, for example, we have estimated the ln YT hat is equal to 6.47 plus 0.0102 T. Okay, this is what we have estimated, and we have let that Y is the population and T is the time. That is already assumed in our earlier cases, that when we are actually deriving the equation, I let YT is the population at the end of the year, T is the respective time or period, and Y0 is the population at the beginning of the year. And when we have estimated this regression function, our value of B1 is equal to 6.47 and B2 is equal to 0.0102 multiplied with your explanatory variable time with T. So here, where the value B2 is equal to 0.0102 means if value of B2 equal to 0.0102 means the relative changes or percentage changes in the population proportional change in the population due to the absolute change in year or time. So more precisely, it means the population of a country has been increasing at a 1.02% per year. So that should be written down here in the next line, that it means the population increases by 1.02% per year. Okay. So you can see that ln/YT hat, which measures the relative or proportional change in the population due to the absolute change in the year or time. So which actually precisely means that the population of your country increased by 1.02% per year. So the B2 equal to 0.0102, it is the percentage change on the dependent variable. It measures the percentage change on the dependent variable, which is followed by here population or YT hat. So when you are written that B2 equal to 0.0102, it means 1.02 percentage change happened in the dependent variable due to the absolute changes of independent or explanatory variable. If we change the time from year 1 to year 2 or from year 2 to year 3, so per year the population has been changed by 1.02%. So that is what explained by the slope coefficient B2 here. So remember one thing, when you are explaining the value of B2 in a semi-log model or growth model, you'll have to multiply 100 while explaining this. তার মানে হচ্ছে আপনার যদি এখানে 0.0102 থাকে সাথে 100 multiply করে in the percentage form, that 1.02% changes happened in the dependent variable from one year to another year or from per year. Okay. So this is the explanation of the value of B2. Now, what is the explanation of value of B1? So you have found that B1 equal to 6.47. What does it mean? Okay. So we know that we have actually let B1 equal to what? We have actually let beta 1 equal to If you can see the earlier derivation, here you can see that beta 1 has been assumed to be ln into y0. Beta 1 has been assumed to be log of y0. Y0 was what? Y0 was the population at the beginning of the year. That means at the beginning or at the initialization of the year, what was the amount of your population? So that is what has been explained by the value of B1, because we are estimating beta 1 in the presence of proxy B1. So when B1 is equal to found like 6.47, it means B1 equal to 6.47. If we can replace the value of B1, because we have assumed B1 equal to ln y0. So if you take the antilog, because 1 by ln means the antilog. Antilog of 6.47. So y0 would have a value after you just press antilog in your calculator multiplied with 6.47. And this value means what? This value means this is the amount of population at the beginning of the year. So it means the amount of population at the beginning of year. So this is how you will explain a semi-log model. Up to this, is it clear to everyone?
Yes, sir.
সবাই বুঝতে পেরেছেন? So in a semi-log model, you'll have to explain two elements, two parameters. One is beta B1, another one is B2. B2 is the slope coefficient, which will be expressed in the form of percentage or relative form. So if you are given B2 equal to 0.012, that means that it shows a relative or proportional changes in the dependent variable of population due to the absolute change in the independent variable or explanatory variable. Here it is time. So which actually means or precisely means that your population, which is your dependent economic variable, this population would be increased by 1.02% per year. Okay, so that is the expression of your slope coefficient in a semi-log model. And how do you explain the value of B1, which is the intercept coefficient or intercept in your semi-log model? So when you are explaining the value of B1 equal to, say, in this model, it is found 6.47. Remember that you have assumed B1 equal to 6.47. That means that B1 equal to ln log form of population or log form of the beginning of the economic variable. So what was the value of the economic variable at the beginning of the year from which you are calculating the growth? So ln of the y0 is our assumption corresponding to the B1. So we have just replaced B1 equal to ln of y0. And then we have take the antilog, because if we take 1 by ln multiplied with the 6.47 value of the B1, so that would appear in the antilog form. And after calculating the value of antilog with 6.47, the value we will get corresponding to y0, it means the amount of population persistent at the beginning of the year. Okay. So is that clear to everyone?
Yes, sir.
Okay. So this is the explanation about the semi-log model. Sometimes you have been asked to calculate the elasticity of the semi-log model. Elasticity of semi-log model. You know that in the semi-log model, it is followed by the log form in the dependent variable, which is equals to B1 into B2 and an independent variable. In the earlier case, it was t, now I am assuming it is x, but this x is not in the ln form, okay, linear form. So what you have to do is, when you are measuring the elasticity of a semi-log model, then this B2, you know that this beta B2, or which is a proxy of the beta 2, it measures the percentage change in y, that means percentage change in the dependent variable, because it is found in the log form, divided by absolute change in x. Absolute change means x will be changed by, x is the explanatory or independent variable which will be changed by absolute form, 1 unit, 2 unit, 3 unit, 4 units. So this is the absolute form of changing. So x will be changed by absolute form, and because of this absolute form changing in the x, how much percentage change happened in the y. So that is what actually estimated by the slope coefficient here in this model, semi-log model. So when you are measuring the elasticity of semi-log model, especially from mean value, if you have said that you have to measure the elasticity of the semi-log model from the mean value, then it is equal to, so percentage change in y. So how to express this? Change in y divided by y, that means difference between the new value of y and previous value of y divided by the previous value multiplied with 100. And how do you express the change in x? Change in x means the difference between the new value of x and previous value of x. So this will remain same. So after that, when you are deriving this, it is like, if you just take the multiplicative form of the dividation form of the change in x, now it would appear in the 1 by delta x, or change in x. And you know that the slope coefficient is delta y divided by delta x. So delta y is in the numerator form, divided by delta x in the denominator form comes here, and 1 by y, and this would be multiplied by 100. Okay, 100 is here. So when you have been asked to measure the elasticity from the mean value means from the mean value of the variables on which is incorporated or which is included in your model. Here the variable is found only y. So we know that there are so many values for the y, there are so many data for the y. So what we have to take here, the mean value of the y. So the elasticity for a semi-growth model or semi-log model is 1 by y bar into 100. Okay, and this one is actually delta y divided by delta x is your slope. So we can write down 1 by y bar into 100, and that is how we can measure the elasticity of model. Is that clear to you? How the elasticity of the semi-log model from the mean value can be calculated. Sometimes in your mathematical problem, you will be asked to calculate the elasticity. So you know that elasticity means the percentage change. So when you are asking to calculate the percentage change in the dependent variable due to the change of independent variable, you know that in a semi-log model like this, the dependent variable has been appeared in the log form, but the independent variable has been appeared in the absolute form. So when you are going to measure the elasticity, you know that this B2, which is the slope coefficient of this model, it measures the percentage change in y due to the only absolute change in x. So percentage change in y can be written down like this and divided by the absolute change in x, and then after algebraic manipulation, delta y divided by delta x is the slope. That means change in y due to the change in x is our slope. 1 by y bar, I have put down y bar here because I already told you that here it is 1 by y, but we cannot take the every value of y here for calculating the elasticity. So when you are going to calculate elasticity, if your y has 10 observation or 12 observation, then you have to calculate 10 times or 12 times of your elasticity. That is not possible. That would be very much cumbersome for you. So what you have to do is you have to take the average or mean value of the y, which is y bar, and then it will be multiplied by the slope coefficient, multiplied by the 1 by y bar, multiplied by the 100. And that is why when you are actually, you can see that here your B2 or a slope coefficient must be multiplied by the 100. So it is because I told you that when you are explaining the value of B2, you have to explain it in the percentage form, because actually you are explaining what? You are explaining the changes in the dependent variable, which is in the log form. And log form dependent variable means your changes in the dependent variable happens in a relative form or percentage form. So that is why when you are explaining the slope coefficient B2 equal to 0.0102, you'll have to explain it with multiplying 100. So once you multiply it with 100, it becomes 1.02%. Okay, and that is actually also found in the derivation of the elasticity, that 100 has been multiplied with the slope coefficient. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. Then apart from the semi-log model, the third model that we are going to discuss is lean log model. This is the third one. In case of the lean log, lean means linear, log means logarithm. So lean log model, there are two variables, you know, dependent and independent or explanatory variables. So in lean log model, the dependent variable side would not be appeared in the log form. It would be appeared in the absolute form. Rather, the explanatory variable would be appeared in the log form. That means it is just the opposite of the semi-log model that we have just completed. Okay, so when we are talking about the lean log model, it looks like y equals to b1 plus b2 ln x. Okay, so when we are estimating a regression model like this, y hat equal to b1 plus b2 ln x. So here it is known as lean log model because the dependent variable has been appeared in the linear form or has been appeared in the absolute form, and the independent or explanatory variable x has been appeared in the log form. So that is why the model has been named after lean log model. Okay. And here, when you are going to explain the slope coefficient B2, how can you explain it? For example, you are going to estimate a regression model like this. Your y hat is equals to minus 125.82 plus another one is 1844 ln x. Okay, here let your y equals to consumption expenditure on service and your x is total consumption expenditure. So your dependent variable is expenditure on service and dependent variable is total consumption expenditure. You know that out of your total consumption expenditure, some of the expenditure has been done on the service. Well, like sometimes you are getting medical service, you'll have to pay for the medical service. Your children are going to the school, you'll have to pay for them for bearing their educational expenses. Okay, and sometimes you are rented in a house, so you'll have to pay per month rent, which is also your expenditure on the service. So this is your y, expenditure on the service, and x is your total consumption expenditure per month or per year. So here, when you are estimated this regression function, you have found that y hat equal to minus 125.82 plus 1844 ln x. Okay, so here how would you explain the value of slope coefficient B2. How do you explain the value of slope coefficient B2? Because you know that here B2 measures what? B2 measures, it measures the absolute change in Y due to the relative change or percentage change or proportional change also, percentage or proportional change in X. Okay, so here we have found that B2 equals to 1844. Okay, what does it actually mean? This 1844 means if X means your consumption expenditure, increases by 1%, I have given X increases by 1% because you can see that in front of the X there is ln. So ln measures what? Relative or percentage value. So here if X is by 1%, then how much Y will be changed? So if X consumption expenditure increases by 1%, expenditure on service which is your Y will be increased by কত হবে বলেন? Will be increased by
1844 unit.
1844 would be directly written as an absolute value.
Yes, sir.
Sure. Sure.
Sir, absolute বলতে হবে কথা 1844 unit.
Actually, it would be written with 1844 divided by 100, which is 18.44 unit. So let me explain why you'll have to divide it with 100. Because I said that if X or consumption expenditure increases by 1%, so here is the percent because of the ln, right? So when I'm saying 1%, so in the absolute form, 1% means what? In the absolute form, 1% means 0.01, isn't it?
Yes, sir.
Yes, sir.
So the value in front of this percentage is written 1844. So when you are saying that X increased by 1%, there is actually 1%. 1% means in the absolute form, it is 0.01. Or alternatively, I can write down 1% is equal to 1 by 100, isn't it?
Yes, sir.
So if it is 1 by 100, multiply 1844, so it becomes 1844 divided by 100.
Yes, sir. Now it's clear.
Okay. So you have to write down that if
Okay.
consumption expenditure increases by 1%, expenditure on the service will be increased by 18.44 unit. Clear? So that is the explanation of the slope coefficient B2, which measures the absolute change in Y due to the relative or percentage change in X. Okay.
Yes, sir.
Now the question is, sometimes here also you have been also asked to estimate the value of elasticity. How can you measure the value of elasticity of lean log model?
Sir, what is the explanation of B1?
Oh, sorry, I didn't explain it, right? So B1 means B1 is found negative 125. Okay, I'll write down it here. So B1 is minus 125.82. So which means if there is no total consumption expenditure, how do you have the expenditure on the service, right? So that's why the value is found negative 125.82. So it means if you do not have any total consumption expenditure for a respective year or for a respective month, that means whatever the time period is, whatever it is, either it is for monthly basis or for yearly basis, it does not matter. Matter is if you do not have any total consumption expenditure, you do not have any expenditure on the service for the respective month. So what you have actually, the real value of the B1 or realistic value of the B1 would be equal to 0. Because as you do any total consumption expenditure, how do you have the expenditure on the service? But you have to remember one thing, that you have your expenditure on the service for the last year. So that means when you do not have the total consumption expenditure on the current year, there are some savings using which you may spend your other expenditure, and out of those other expenditure on the service may be also covered. So in really, there is no expenditure on the service happened in the current year, because you do not have any total consumption expenditure on the current year. So when you are explaining this, write down that as B1 is equal to found minus 125.82, which means if there is no total consumption expenditure, that means if X is equal to 0, there is no total consumption expenditure for a respective year or for a respective month, the expenditure on service would be practically 0. Okay. But here in the mathematical value, as per the economic data or mathematical data, we have found that B1 equal to minus 125.82, which do not have realistic or economic meaning. Because we know that if I do not spend anything for a respective year, if I do not spend anything for a respective month, then how would I say that the expenditure on the service is this amount? So when I get the minus value, which means that actually, realistically or practically, it means the expenditure on the service is 0. And we have to write down the explanation like this: if there is no total consumption expenditure, assuming X equal to 0, the expenditure on the service would be practically 0. So there is no economic meaning of B1 equal to minus 125.82. Does not have any economic implication. Okay. Is that clear to everyone?
Yes, sir.
So what I was talking, that how can you measure the elasticity of the this kind of model, like lean log model or linear log model. So here the same thing also applied, that when you are assuming a lean log model, so it is yt equals to your B1 plus B2 into ln form of X or log form of the X. So which actually measures what? Which actually measures the absolute change in Y divided by percentage change in X. That means due to the 1% change in your explanatory or variable X, how much absolute change happened in the dependent variable Y. So that is what actually measured by the slope coefficient B2. Now, when you are going to estimate its elasticity of lean log model, especially from the mean value, like the earlier one we have estimated for the elasticity of the semi-log model for the from the mean values. So it would be followed by delta Y, the absolute change in the Y, and percentage change in the X is X divided by X into 100. So you have delta y in the numerator, and when you have given that the division in the multiplicative form, it would be looks like x divided by x into 100. So delta y divided by delta x. So you have actually x divided by 100. Or we can say that delta y divided by delta x is our slope. And if you want to calculate the elasticity for every value of x, that would be very much cumbersome for you. That's why we are taking average value of the, or mean value of the x variable, and will be divided by 100. So you can see that with the slope coefficient, we can also write down it like this, that is slope divided by 100 into x bar. Okay, that is the last derivation we can use to estimate the elasticity for a lean log model. So you can see that, as I told you earlier, that you have to divide the slope coefficient with 100 because of this derivation, because the slope B2 value would be definitely divided by the 100. Okay. So আমরা একটু আগে দেখলাম না যে স্লোপ কোএফিসিয়েন্টটাকে আমরা 100 দিয়ে ডিভাইড করছি, 1844 divided by 100 is equal to 18.44 unit. So that is the reason for which we are actually dividing by 100. I have already explained you why 100 should be divided with the slope coefficient because of showing the percentage change in the independent variable or explanatory variable. So here it is also again proof that your slope coefficient must be divided by 100 when you are explaining the value of B2. So this is how we can calculate the elasticity of the lean log model from the mean value. So up to this, is it clear to everyone?
Yes, sir.
Okay. Then another one is reciprocal model, number 4. In case of the reciprocal model, the model has been named after reciprocal model because the independent variable or explanatory variable has been given in the input of the model as a reciprocal form or in the inverse form. So in a reciprocal model, the model looks like yt equals to b1 plus b2 1 by x. Okay, so that means your independent or explanatory variable will be inserted in a inverse form or in an inverse form or in a reciprocal form. Okay, and when you are actually going to use the reciprocal model, how do you explain the value of B2? Of the value of B2 depends on the graphical representation of this model. So when you are graphically plot this model, y equal to b1 plus b2 multiplied with 1 by x or 1 by xt if it is for time variable, if it is for the variable related to the if it is for the variable corresponding to a time, that means time series data. If it is holding the time series data, then the explanation of the B2 or the slope coefficient would be dependent on the graphical representation between the y variable and x variable. Sometimes we will use the reciprocal model for different economic scenario. For example, if we want to see that average fixed cost, movement of that or changes in the average fixed cost. Okay, so when we are actually assessing that how much average fixed cost will be changed when we increase the number of unit, when you increase the number of output in a production unit, how much average fixed cost will be changed. So for showing the movement of the average fixed cost with the movement of the number of output you have produced, we have to use the reciprocal model, because we know that if you are increasing the number of output, the average fixed cost will be definitely decreased. isn't it? Fixed cost will remain same. When you are dividing with number of quantity, if you are increasing this number of quantity, this average fixed cost, AFC, average fixed cost will be definitely reduced, isn't it?
Yes,
Yes,
sir.
sir.
Yes, sir.
So when you are actually showing this relationship graphically, how do you show them? Say this is your x-axis showing the number of output, and this is your y-axis showing the average fixed cost or AFC. Okay. So that means in the reciprocal model, your y is holding the value of average fixed cost, your x is holding the value of output. So in that case, when you are actually increasing the number of output from 0, 1, 2, 3, and so on, the movement of your average fixed cost would be like this. Okay, like this. It would remain constant at one point of level. Why? Because, this is the point, because it would remain constant at this point. Say if you increase further quantity after at this point, this will remain equal to B1. Why it will remain equal to B1? Because just look at the reciprocal model. Your output is given. Your output is given 1 by x. X is your output here. Okay. So if you increase the volume of output, if you increase the number of output, this value 1 by x will approaches to the 0, isn't it? মানে আপনি যদি x এর ভ্যালু বাড়াতে থাকেন, বাড়াতে ধরেন 1 divided by 1000, it would produce 0.0000 something, নাকি? বুঝতে পারছেন আপনারা? না আমি আবার বলবো?
হ্যাঁ তাহলে 6 দিন
So are you listening to me?
Can you mute Abu Rahan,
Repeat,
sir?
sir.
Yes, I'm going to mute all of them. So I'm explaining again that reciprocal model, when you are using the reciprocal model, for example, you are going to show the relationship between the movement of the average fixed cost and the number of output you are producing. Your average fixed cost, which would be measured by total fixed cost divided by number of quantity, this is equal to your average fixed cost. And I said that when you are graphically representing this model, it would be looks like a curve which would be started from here. So this is your average, this is the initial position of your average fixed cost. This is the initial position of your average fixed cost at the 0 level of quantity. You know that there are two types of cost. One is fixed cost, another one is variable cost. And fixed cost will remain fixed. Fixed cost will remain fixed even if you are not producing any quantity. Okay. So your average fixed cost, you are showing it in the y-axis. Say it would be started from number 1 quantity. It would not be started from the 0 quantity. Why? Because if you divide fixed cost with the quantity equal to 0, it shows the undefined. It shows what? Undefined. 0 quantity te kono dhoroner average fixed hobe na. It shows undefined. Okay. But from the quantity number 1, your average fixed cost will be. That's why I have started the curve from this point. Okay, from this point. From the quantity number 1, your average fixed cost will be started, and it would be deteriorated or decreased if you are increasing the number of quantity. Okay. I said that how long this curve or how long this line will be decreased. This line will be decreased equivalent to the value of a constant, which is followed by the value B1. So Y, which is showing the average fixed cost, it would be equal to the B1 at one point of time if you produce a large amount of volume of output. Why it would be equal to the B1? Because this portion, this circle portion B2 into 1 by X has become 0 when you are increasing large volume of output. The reason is as I said, that 1 by x is the independent variable which has been inserted in your reciprocal model. This 1 by x means what? Your output level. So if you increase the level of output, level of production in your company, say this is, you are producing 1000 quantity or you are producing 2000 quantity. When you write down 1 divided by 2000 or 1 divided by 1000, it would produce a value which is 0.0000 something. That means 1 by x would be approaches to 0 when you increase the number of output. Isn't it?
Yes, sir.
Yes, sir.
So in that case, if it is approaches to 0, at one point of time, maybe it would be exactly equal to 0 or it would be almost equal to 0. So if it is 0, then this portion will become also 0. Or this portion, in that case, this portion will become, if 1 by x would be approaches to 0, then if you multiply it with B2, whatever the value of your slope coefficient, doesn't matter. It would be actually equal to the approximately 0. So that means this portion would have a value of 0. This portion, B2 into 1 by x, this portion would have a value of 0. If it is equivalent to the 0, then your average fixed cost followed by YT is equal to B1. And that is what B1 I have written down here. So even if you are producing huge amount of quantity, at one point of time, your 1 by x has become 0, approaches to the 0. And if it is multiplied with the slope coefficient, it would be also approaches to the 0 because they are in the multiplicative form. So in that case, your average fixed cost, YT, would be equal to exactly B1. And that is why the curve has become downward, but at one point of time, it remains constant. এরপর থেকে এটা এইভাবে যাবে। মানে এটা constant B1 equal to সমান হয়ে যাবে। Whatever the level of quantity you are producing, 7, 8, 9, doesn't matter. Is that clear to everyone?
Yes, sir.
Okay, now what is the implication of this? Why I have written down this, why I have shown this relationship between average fixed cost and the level of output producing? Because I want to show you that how do you explain the value of slope coefficient B2? How do you explain the value of a slope coefficient B2? The explanation is, from your earlier discussion, I told you when you are watching that in a graphical representation between the dependent and independent variable, it shows a curve. The slope coefficient from one point to another point, the slope coefficient from one point to another point is not constant. Slope coefficient is not constant in a curve. So that's what I have discussed in the earlier class, if you just recall the earlier class, isn't it?
Yes, sir.
Yes, sir.
But if you just go through a graph where the straight line is here, and in that straight line, the slope coefficient, that means the distance between 2 points from one point to another point, the distance is constant here. Okay. This average fixed cost curve corresponding to the level of output is a curve. It's not a straight line. So in this curve, from one point to another point, the slope coefficient, which is measured by B2, will not remain constant. So if your B2 value, say, found 8.72, this 8.72 doesn't mean that if you increase the, if this 8.72 minus, it definitely you will get it in the minus, you definitely will get it in the plus form, but that will be in the minus form because you have inserted x in an inverse form. You have inserted in the model in an inverse form. So when you are explaining the value of B2, you have to remember that as the slope coefficient B2 will not remain constant from one point to another point in a curve because of being a curve. So the explanation of the B2 will be, if the level of output increases by 1 unit, then the slope coefficient, which is followed by 8.72, will not remain constant at every level of output. I repeat, the explanation would be followed by, when you are written that B2 equal to 8.72, it means if X, that means your output, increases by 1 unit, if your X or output increases by 1 unit, average fixed cost would be decreased by 8.72 unit. That is the explanation you would have to write down, okay? But you'll have to write down an additional line along with this explanation, and the line is this slope coefficient B2 equal to 8.72 will not remain constant at every level of output followed by X. So it means this 8.72 unit is the slope coefficient which will not be applicable, being a constant value for the changes of every of the output level from one point of the output level to the another point of the output level. But when you are writing down this, the explanation should be written down like this, that B2 equal to 8.72, it means if X increases by the 1 unit, average fixed cost would be decreased by 8.72 unit. But remember that you have to write down an additional line with this slope coefficient B2 equal to 8.72 will not remain constant at every level of output. Now you can ask me why this actually will not remain constant. Because as I told you, this is a curve, this is not a straight line. So the value of B2 is showing the slope coefficient. So from one point to another point of the slope coefficient will not remain constant here. Maybe on an average, it is found 8.72. But if you just mathematically measure it from unit 1 to unit 2, or from output level 2 to output level 3, at every level of output, you will not get the same value 8.72. You will get sometimes 6 point something, sometimes you will get 7 point something, sometimes you will get 9 point something. So this is the different value produced by this curve, average fixed cost curve. And as it is a curve, because of its nature, you will not get the slope coefficient which will remain constant at every level of the output. And that is what you have to explain here when you are giving a reciprocal model in your regression function. Okay. Is that clear to everyone?
Yes, sir.
Yes, sir.
There is another thing I have written down. You can see that B2 equal to plus 8.72. But when I am explaining, I have written down opposite language. Why?
এটা রেসিপ্রোকাল বলে অপোজিট এ বলছি কারণ একটা ইনক্রিজ
Exactly.
করলে একটা ডিক্রিজ করবে
Okay. So if means X increases, Y will be decreased. So the slope coefficient would be found here as positive. But if you just fit this data in a normal linear model like Y equals to B1 plus B2X, where Y is your average fixed cost and X is your output level, then your value of B2 definitely would have a minus sign or negative sign, because you know that when the output level has been increased or the number of output you are increasing, then the average fixed cost will be decreased. Okay, so in the linear form you will get the value of B2 in the negative form. So in the reciprocal form, that same value of the B2 would be found in the positive form, because here the independent variable X has been inserted in a opposite form or reciprocal form. So is that clear to everyone?
Yes, sir.
And sir, I have a question, sir.
Sure. Ji,
So
bolen.
from economic point of view,
Sorry.
can we say that from economic point of view, can we say that
Please repeat
average
the
fixed
question.
cost always reduce?
I did not get you. Would you please repeat your question?
Can you hear me, sir?
Yes, now I can hear you.
Sir, I'm saying that from economic point of view, can we say that average fixed cost always reduce at a non-constant rate?
average fixed cost would be reduced at a non-constant rate, not a constant rate. Non-constant rate because sometimes in the production level, sometimes in one volume you have produced 100 units, another volume you have produced 150 units. In another volume you may produce 200 units. So the volume of unit will not remain constant here. So in that case, your average fixed cost will not produce a constant elasticity or constant slope coefficient. So it would be varied from one level of output to the another level of output. Actually, the explanation here would be that when you are given that B2 or any slope coefficient equal to a specific value, so it means that in the reciprocal model, when we are actually adjusting this value B2 equal to something value, then the percentage point rate change in the change in your percentage point rates change in your what I say a fixed cost, average fixed cost is not actually constant, because here if it is constant then it would be a straight line. As I am saying that it is actually a curve, it is actually a curve, and at one point of time it will remain constant at equivalent to the B1. So when it will remain constant equivalent to 1, you can see that there would be a numerous or huge amount of volume of production will be happen. And mathematically, when we are actually adjusting this or showing this graphically, it is showing a constant line. But if you are just asking me that whether it is possible economically, yes, economically it is possible. Because at one point of time, whatever the number of volume you are producing, your fixed cost will remain as a constant, because you have appointed preliminary basis, you have appointed 5 laborers or 6 laborers or 7 laborers, or you have appointed some raw materials. On the preliminary basis, some of the raw materials have been wasted. But when your production basis or when your machineries, when your labors have become efficient with the level of production, then your cost will remain, this fixed cost will remain constant. But up to that level, when you are increasing the level of production, then because of the economies of scale and because of the diminishing rate of return, you heard about the diminishing marginal
Yes, sir.
rate of
Yes, sir.
So because of those two factors, diminishing marginal rate of return and because of the economies of scale, your average fixed cost will be in the downward trend. And at one point of time, it will remain constant when all the labors and all the input or all the raw materials have become efficient in producing the output. Okay.
Okay, sir. Thank you.
So if it is clear to everyone, there is another example along with this. So that example should be solved by a mathematical problem, I think. This is from the page number from the 4th edition. It is page number 169, problem number 5.13. And from the 3rd edition, this is from problem number 9.13. Okay. So 5.13 is the problem number from 4th edition, and 9.13 is the problem number from 3rd edition. So this is a problem regarding the reciprocal model. So you are given that based on the UK data on the annual percentage change in wages followed by Y, that means your dependent variable is percentage change in wages, and the percent annual unemployment rate for the years 1950 to 1966, the following regression results were obtained. So you are given a reciprocal model where the dependent variable is percentage change in the wage rate, and the independent variable is the annual percent of the unemployment. Simply, it is unemployment rate for the given years. There are 17 years data or observations have been included, and after using those observations, they have found the estimated regression model YT hat equal to minus 1.4282 plus 8.7243 multiplied by 1 by x. Okay, Now, the questions are given, the standard deviations are also given, R square value is also given, F value is also given. The question is given that number A. What is the interpretation? What is the interpretation of 8.7243? Can someone say, please tell me what is the interpretation of this? How to write down the interpretation here? The slope coefficient, which is B2 equal to 8.7243. What does it mean?
So if the
Yes.
output increases by 1
It's not the
unit,
output, it's the percentage change in wage rate. In your mathematical problem, the Y is here. Let me write down the question, okay? Your Y is here as percentage change in wages, and your X is here, unemployment rate. You are, okay, unemployment rate. Now, if you are given that B2 equal to 8.7, so your estimated regression model is minus 1.4282 plus 8.7243 divided by 1 by X, okay. So this is you have estimated. Now, what does B2 equal to 8.7243 mean? Where Y equal to percentage change in wages and X equal to unemployment rate.
Sir, if unemployment rate যদি আমার ইনক্রিজ করে তাহলে আমার ওয়েজ রেট ডিক্রিজ করবে, যে পরিমাণ পার্সেন্টেজ আনএমপ্লয়মেন্ট রেট ইনক্রিজ করবে, আনএমপ্লয়মেন্ট রেট ইনক্রিজ করার মানে তোমার ওয়েজ রেট ডিক্রিজ করবে।
But you have to write down that additional line, okay?
ইয়েস স্যার, যে সবসময় এটা কনস্ট্যান্ট থাকবে না।
কনস্ট্যান্ট থাকবে না। সো এটা পারবেন না লিখতে হবে আমার সবাইকে জিজ্ঞেস করছি।
পারবো স্যার।
স্যার পারবো।
ওকে, সো এডিশনাল লাইনটা আমি লিখে দিচ্ছি, সেটা একটু খেয়াল রাখবেন যে the rate of change in wage earnings will not remain constant. Rather, it depends on what level of unemployment rate or X, what level of X, which means your unemployment rate, what level of unemployment rate the change is measured. Okay. So this B2 equal to 8.7243, this rate of change of wage earnings will not remain constant. Rather, it depends on what level of your X, what level of your unemployment rate the change is measured. On what level of your unemployment rate the change of wage earnings is measured. Okay. So after that, number B. Is that the estimated slope coefficient is not different from 0. Which test will you use? Which test will you use? Hypothesis test করতে বলেছে।
t-test use করব।
We will use t-test because the number of observation is here less than 30, and we actually do not know the population variance or population error, population variance or population standard deviation. So that's why we have to use the t-test. So here, when we are using the t-test for the hypothesis, so first of all, let slope coefficient is B2, which is actually the proxy of the beta 2. So we know what? Unemployment rate and your percentage change in the wage earnings. What would be the relationship as per the economic point of view between inverse, right? So which kind of test you are going to implement here, one tail or two tail?
Sir,
inverse
one tail
relationship
test because only plus sign আমরা consider করতেছি.
exactly. So as we are actually considering a reciprocal model x centered with the inverse form, so the value of the slope coefficient will be always positive. Okay, so we'll use the one tail test. So b2 is greater than 0 is the null hypothesis, and your alternative is b2 is less than or equal to 0. And then perform your usual test of significance approach for the t-test. So b2 minus null hypothesized value of the beta 2 divided by standard deviation of the b2, which is calculated based on the sample, and your b2 value here is 8.7425 7243 minus your null hypothesized value of beta 2 is 0 and divided by the standard deviation is 2.8478, which is equal to কত আসে দেখেন 8.7423 7243 8.7243 divided by 2.8478
3.06.
3.064. Now if you are going to the t-test, so you are looking at the plus value. So in the positive side, all the 5% level of significant would be scattered on the side or positive distribution. So here your t is on the middle is 0 and your calculated t value is from 3.064, but at 5% level of significance, the degrees of freedom is, what would be the value of degrees of freedom? Your n is here, how many years of observation you have included from 1950 to 1966, 17 years. So it would be 1 minus k, the degrees of freedom, which is followed by 17 minus, there are two parameters, unknown parameters. There were two unknown parameters. One was B1, another one is B2. So that's why we are deducting minus 2. So degrees of freedom is 15. And after that, as per your tabulated value or critical value given at the end of your text, you can see that at the 5% level of significance for the t distribution corresponding to 15 degrees of freedom, it is written 1.753. Okay. So your critical value as per the is 1.753. Okay, and your calculated value is found 3.064, so it is fallen under the level of significance area. That means you can reject the null hypothesis. Reject null hypothesis. So B2 value, so it is what? Statistically significant or insignificant? You are rejecting null hypothesis. Null hypothesis was what?
Significant. Better than 0.
You are rejecting that. The alternative is accepted, which means B2 should be less than or equal to what? 0. That is the hypothesis you have accepted, right? Now, what is your conclusion when you are rejecting null hypothesis? What is your conclusion? It is statistically significant, not insignificant.
Significant.
When you are rejecting null hypothesis, it is statistically significant. That is the language we know, right?
Yes, sir.
Okay. কিন্তু আপনার কি ক্যালকুলেশন এটা মিলছে দেখেন তো again just look at your null hypothesis. Your null hypothesis was beta 2. That means the parameter of beta B2 is the proxy of beta 2. So this beta 2 value should be greater than 1. That was the greater than 0. That was your null hypothesis according to your economic point of view, right? কিন্তু যদি আপনি এটা রিজেক্ট করেন তার মানে অ্যাকসেপ্ট করছেন কোনটা, বিটা 2 is less than or equal to 0, isn't it?
Yes, sir.
Yeah.
তার মানে কি আপনি বিটা 2 is less than or equal to 0 পেয়েছেন, b2 equal to কত পেয়েছেন?
8.7243.
So you have done a mistake in
স্যার
assumption.
আমাদের ইকোনমিক পয়েন্ট অফ ভিউ সবসময় অল্টারনেটিভে আসে না?
Exactly, এটাই আমি বলতে চাচ্ছিলাম যে when I am actually assuming null hypothesis beta 2 is greater than 0, or alternatively আমি বলছি beta 2 is less than or equal to, because equal sign should be always given in the alternative hypothesis, and researchers hypothesis would be always reflected in alternative hypothesis. আপনাকে hypothesis ধরতেই হবে এভাবে যাতে আপনার যেটা অবজেক্টিভ, the objective that you have in your mind, that objective should be tested significantly here, or should be found statistically significant in your t-test or whatever test here. আপনি যেটা চাচ্ছেন সেটাই যাতে আপনার টেস্টে আসে, সেইভাবে পয়েন্ট অফ ভিউ থেকে আপনাকে হাইপোথিসিস সেট করতে হবে। তা আপনার অবজেক্টিভ হচ্ছে, আপনি জানেন যে ইন এ রেসিপ্রোকাল মডেল দ্য কোএফিশিয়েন্ট ভ্যালু অর স্লোপ কোএফিশিয়েন্ট ভ্যালু উড বি পজিটিভ। 8.72 পেয়েছি, এটা আমরা পজিটিভ পেয়েছি, এবং অ্যাকর্ডিং টু ইকোনমিক থিওরি উই নো দ্যাট ইন এ রেসিপ্রোকাল মডেল দেয়ার ইজ এন ইনভার্স রিলেশনশিপ বিটুইন y and x even if the slope coefficient is positive, because the x has been imported here in the inversely. x ইনভার্সলি ঢুকছে বলে এটার এক্সপ্লেনেশনটা হচ্ছে যে পজিটিভ কোএফিশিয়েন্ট পাওয়া সত্ত্বেও আমরা এক্সপ্লেন করার সময় এটাকে ইনভার্সলি এক্সপ্লেন করি। তা আমি জানি যে এখানে অ্যাজ পার দ্য ইকোনমিক পয়েন্ট অফ ভিউ দ্য ভ্যালু অফ b2 শুড বি পজিটিভ। তার মানে আমার হাইপোথিসিসটা ধরার সময় ধরতে হবে এভাবে, দিস ইজ দ্য মিস্টেক আই হ্যাভ ডান। beta 2 should be greater than or equal to 0, and in the null hypothesis beta 2 is less than 0. এখন ঠিক আছে কিনা দেখেন তো।
স্যার নো ডিফারেন্ট ফ্রম জিরো বলতে কি বোঝানো হয়েছে কোশ্চেনে?
কোথায়?
কোশ্চেনে যে নো ডিফারেন্ট ফ্রম জিরো,
that the estimated slope coefficient is not different from 0. So is not different from 0 মানে হচ্ছে যে এটা 0 না, এটা যে 0 না, it's different from 0, এটা আপনাকে টেস্ট করতে বলেছে। it's different from 0, এটা আপনাকে টেস্ট করতে বলেছে। সো যখন আপনাকে বলছে যে টেস্ট দ্য হাইপোথিসিস দ্যাট দ্য এস্টিমেটেড স্লোপ কোএফিশিয়েন্ট b2 is not different from 0. So if it is different from 0, then there is an implication of this model. So if it is equal to 0, then there is no implication of this model. সেইভাবে হিসাব করলে আপনাকে হাইপোথিসিস ধরতে হবে টু টেল টেস্ট করে, যে b2 equal to 0 আর beta 2 not beta 2 equal to 0 আর beta 2 not is equal to 0, এভাবে করে ধরতে হবে। কিন্তু আমরা জানি কি ইকোনমিক পয়েন্ট অফ ভিউ আমাদের যখন হাইপোথিসিসটা সেট করতে হয়, from the economic point of view, always we have to consider the researcher's hypothesis should be reflected in the alternative hypothesis. সেই অনুযায়ী hypothesis ধরতে হবে, if I am going for the one tail test, it would be followed by H0, beta 2 is less than 0, and H1 is beta 2 is greater than or equal to 0. এইভাবে করে ধরতে হবে। Now it has been consistent with your findings. Okay. And another thing is, when you are actually doing this kind of hypothesis, remember one thing that,
স্যার
yes,
আমরা যখন b2 গ্রেটার দ্যান অর ইকুয়াল টু 0 ধরছি, তার মানে তো b2 ইকুয়াল টু 0 হতে পারে, সেটা বোঝায়। তাহলে
এই
ডিফারেন্স
যে ইকুয়াল টুটা এখানে আছে, এই যে এখানে আছে, okay, it is exactly 0 or greater than 0. Equal to দিতে হবে, alternative hypothesis always should have the equal to 0, and null hypothesis does not include the equal sign. এখানে কখনো equal sign, সরি আমি তো উল্টা করলাম, সরি ভুল করছি। নাল হাইপোথিসিসে সবসময় ইকুয়াল সাইনটা দিতে হবে, তাহলে এটা লিখতে হবে এইভাবে উল্টা করে। এখানে এটা হচ্ছে ইকুয়াল সাইন, আর এটা হচ্ছে greater than 0. Now always remember that null hypothesis includes the equal sign, and alternative hypothesis never ever includes equal sign. এটা মনে রাখবেন সব সময়. That is the universal truth when you are setting the hypothesis. null hypothesis এর কোনো মানে আপনাকে ইকুয়াল সাইন দিতেই হবে, সেটা আপনি এখন যেভাবেই দেন, লেস দেন সাইন দিয়েও নিচে দিয়ে ইকুয়াল দিতে হবে, অথবা গ্রেটার দেন দিলেও নিচে দিয়ে আপনাকে একটা ইকুয়াল সাইন দিতে হবে। But alternate hypothesis never ever includes any equal sign. Okay, it is always either greater than sign or less than sign or not equal sign. তিন রকম সাইন হতে পারে। এটা আমি maybe I have told you in the second or third chapter when we are discussing about the test of hypothesis, যে null hypothesis always includes the equal sign, either in the exact equal sign or less than equal or greater than equal, এরকম করে থাকতে হবে।
স্যার রিসার্চারের হাইপোথিসিসটা কিভাবে সেট করবে আবার একটু বললে ভালো হতো।
হ্যাঁ, রিসার্চের হাইপোথিসিস যেটা বলছিলাম আমি, আচ্ছা এটা লিখে নিই জাস্ট। অল্টারনেটিভ হাইপোথিসিস নেভার এভার ইনক্লুডস ইকুয়াল সাইন, নট ইকুয়াল হবে এখানে, অথবা গ্রেটার দেন হবে, অথবা লেস দেন হবে। ওকে, আচ্ছা যেটা বলছিলাম যে হাউ ক্যান ইউ সেট দ্য রিসার্চার্স হাইপোথিসিস। রিসার্চার হাইপোথিসিস উড বি অলওয়েজ ডিপেন্ডেন্ট অন ইউর ইকোনমিক পয়েন্ট অফ ভিউ, and researcher hypothesis would be always reflected in the alternative hypothesis, not in the null hypothesis. আপনি চান যে আপনার হাইপোথিসিস যেটা আপনি চাচ্ছেন as per your objective, ইনফ্যাক্ট এটা আপনি চাইলেও হবে না, আপনি ইকোনমিক পয়েন্ট অফ ভিউতে বা লজিক্যালি বা লজিক্যাল পয়েন্ট অফ ভিউতে অথবা ইকোনমিক মিনিং এ আপনি চাচ্ছেন যে আপনার পয়েন্ট অফ ভিউটাকে রিফ্লেক্ট করানোর জন্য। মানে আপনার পয়েন্ট অফ ভিউটা হচ্ছে যে when the unemployment rate has been increased, then the wages or the earnings wages or rate of the earnings of the wages will be decreased, because in that case the laborers will lost their negotiation power because of high unemployment rate. Okay, that is the economic point of view. You know it. So according to this, you know that when you are setting a reciprocal model like y equal to 1 by x, your y is the unemployment rate, 1 by x is your here, sorry, your y is the earnings or wages, and x is your unemployment rate. আপনি আনএমপ্লয়মেন্ট রেটটাকে দিচ্ছেনই এখানে ইনভার্স করে, তার মানে যখন আপনি এটাকে ইনভার্স করে দিচ্ছেন, ইট মাস্ট হ্যাভ অ্যান inverse impact or adverse impact on the dependent variable. And how do you assess this inverse adverse impact? By watching the slope coefficient value, and it is found 8.7243, and you can see that here it is in a positive value found. So positive value will definitely found because you have inserted the inverse form of the x or inverse form of the independent variable. That's why here it is found positive. আপনি যদি এটাকে আবার লিনিয়ার ফর্মে করতেন তখন এটাকে পেতেন আপনি নেগেটিভ, যে ধরেন y ইকুয়াল টু b1 plus b2x, এই ফর্মে যদি ইনপুট দিতেন, if you give the input of the unemployment rate of x in the linear form, then you will get the value of b2 in the negative form, negative something পেতেন, this is negative 7 point something like that. Okay, so you know that there is an inverse relationship, and when you are doing the reciprocal model, the value of the slope coefficient would be positive for an inverse relationship. Of a slope coefficient would be positive for an inverse relationship between x and y. তো ফাইন, আপনি সেই অনুযায়ী যেটা করলেন যে যদি value of slope coefficient would be found positive to show an inverse relationship in a reciprocal model, then my alternative hypothesis has been set with beta 2 is greater than 0. In that
Yes, sir.
case, I will get the
Clear.
positive relationship. Fine.
Yes, sir. Clear.
এখন দেখেন বাকি সবাই বুঝতে পারছেন কিনা। Is that clear to everyone?
Yes, sir.
Okay, then number C. How do you use the f-test statistic to test the preceding hypothesis? আগের hypothesisটাতে slope coefficient significant কিনা বা whether the slope coefficient is statistically significant or not, we have tested it using the t-test. Now you've been asked to assess that whether you can use the f-test to test the preceding hypothesis. You know that f-test assesses the joint or overall significance of regression model. F-test assesses the joint or overall significance of the regression model. So according to the value of F, with the degrees of freedom in the numerator 1 and 50, 9.39 means, compared to the tabulated value or critical value given at the end of your text, in the F table, if you just look at the Fisher's table or Fisher's distribution or F distribution table at the end of your text, the numerator is 1, denominator is 15, numerator is 1 degrees of freedom and denominator is 15 degrees of freedom. For 5% level of significance, the critical value of F is given 4.54.
Yes, sir.
So this is your level of significance area, where the critical value of F at the 5% level of significance corresponding to 1 and 15 degrees of freedom is given 4.54. So up to this, if your calculated value is fallen within 4.54, it is fallen under the acceptance area. But your calculated value is showing that it is found 9.39. It is found 9.39. 9.39 is the level of significance area. Okay. So if it is found level of significance area, we can say that we can reject the null hypothesis of the F-test. The F-test null hypothesis was what? F-test null hypothesis ki hoy? R square is equal to 0 or R square not is equal to 0. Naki? Have you forgot the F-test?
কারণ আর স্কয়ারের মান তো স্যার কখনো হচ্ছে গিয়ে 0 এর কম হবে না, নেগেটিভ হবে না।
Exactly. So let null hypothesis R square equal to 0 and alternative is R square not is equal to 0. In that case, when you are doing the F-test and you have found that the calculated value of X is 9.31 and your tabulated value is given 4.54, it is fallen under the level of significance area. So you are rejecting this null hypothesis, reject H0, right? So it means your statistical significance is found for the overall statistical or joint statistical significance is found for the said estimated regression model. So F equal to 9.39 means we can reject H0, which precisely means that the model is statistically jointly significant. Okay, statistically jointly significant manei hocche R square value is not equal to 0. Statistical significance word, it means the parameter value is not equal to 0. When the parameter value is not equal to 0, we can say that this parameter is statistically significant. Okay, is that clear to everyone?
Yes, sir.
So here another thing is number D. Given that your y bar value is 4.8 and your x bar value is 1.5, x bar value is 1.5%, what is the rate of change of y at these mean values? Okay. Given that your y bar value is 4.8% and x bar value is 1.5%, what is the rate of change of y at these mean values? So you know that your rate of change values would be estimated by the B2 or a slope coefficient. And here you are given that I told you for a reciprocal model. For a reciprocal model, when you are assessing the B2, it is actually assessing what? Here in this calculation, it is actually assessing the percentage change in y, change divided by change in the inverse of the x. Change in the y divided by change in the inverse of the x. So when you are actually calculating the value of the value of the slope coefficient here followed by B2, this slope coefficient measures here actually your percentage change in, sorry, not B2, it's your elasticity. When you're calculating the elasticity here, it is actually percentage change in y divided by percentage change in inverse of x. Inverse of x can be written down x to the power minus 1. Can I write down 1 by x equal to x to the power minus 1?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So here it is delta y divided by y into 100 divided by your percentage change in x to the power minus 1. So it means delta x to the power minus 1 divided by your x to the power minus 1. And this is also multiplied by 100. So 100 has been crossed. So what you have is delta y divided by y multiplied with x to the power minus 1 divided by delta x to the power minus 1. So after that, delta y divided by delta x to the power minus 1 into x to the power minus 1 divided by y. So here it is actually delta y divided by delta x to the power minus 1 means how much changes in the y happened if there is 1 unit change by the inverse of x. How much changes happens in the y if there is 1 unit changes happened in the inverse of x. So it is actually the slope. And it is equal to the x to the power minus 1 divided by y. So we can write down it as slope into 1 by x divided by y, which can be further written as slope into 1 by x into y. If you just take the multiplicative form, so it becomes slope into y by x. Did you get this derivation? Slope into y by x.
Yes, sir.
দেখেন এটা বুঝতে পারছেন কিনা সবাই? একদম ভেঙেই করেছি, আর ওর থেকে তো আর ভাঙতে পারি না। Okay.
Yes, sir.
Yes, sir.
Now here the slope is multiplied with y by x, so we cannot multiply the slope every time with every observation of y with every observation of x. What we actually take here, y bar divided by x bar, isn't it? Yeah. Now just multiply your slope value. Slope value is 8.7243 and multiplied with your y bar value is 4.8, bar value is 1.5, which is equal to কত আসে দেখেন ক্যালকুলেট করে
27.92.
So this is the rate of change with mean value. This is the rate of change with mean value, 27.92. Is that clear to everyone?
Yes, sir.
Yes, sir.
So rate of change of what? Rate of change of y, rate of change of y with the mean value. Y means your earnings or wage earnings. So this is about number koto kollam C or D. It's about number D, then number E. What is the elasticity of y with respect to x at this mean value? Same question actually, just you will have to replace the value. Here elasticity would be measured as we know that slope multiplied with x bar multiplied with y bar or x divided by x bar multiplied with y bar okay. So here you can see that it was y bar divided by x bar, and all of these values 4.8, 1.5, 8.72, 27, 8.7243, all of these values are actually percentage form. So what you have to do is to just write down their absolute value. 8.72 percentage can be written down 0.08724. Y bar is written as 4.8%. We can write down it 0.048, and X bar is written 1.5%. We can write down it 0.015. So which will produce that 0.27 কত আসছিল value এখানে 27.92. So in the absolute form it is now 0.02792. No, sorry, 0.2792. 27.92 আসছিল তো, এটাকে আমরা যখন absolute form এ লিখবো with the multiplication of this value, then we will get 0.2792. Okay. Is that clear? The calculation to everyone?
Yes, sir.
মানে একই ক্যালকুলেশন, ওইখানে আমরা পার্সেন্টেজ ভ্যালু ছিল, ওগুলো হচ্ছে সবই পার্সেন্টেজে দেওয়া 8.72%, 4.8%, 1. Everything was in percentage form. Now we have just replaced their absolute value and calculating the elasticity in terms of the absolute form. And the last one is number F. How do you test R square equal to 0? We know that our null hypothesis R square equal to 0. Alternative is it's not is equal to 0. And how do you test considering the R square? Using which test? F test.
F test.
Yes, because F test is the only test that produces positive value. And R square always produces positive value. So F test is equal to, in the numerator portion of the F test, the explained sum of a square, which is followed by R square. So here it is R square divided by degrees of freedom, which is n minus k. And in the denominator portion, 1 minus R square divided by n minus k. In the numerator টা একটু ভুল হয়েছে, এটা হবে k minus, sorry, it is k minus 1. K minus 1. Okay. This is the formula of calculating F test ratio for testing the null hypothesis that R square equal to 0. So our R square value is given here, very low R square value, 0.3849 divided by K. K means your number of parameters in the model. There are two parameters, B1 and B2. 2 minus 1 and 1 minus R square in the denominator portion, 1 minus 0.3849. Which is divided by minus k. N means your total number of observations 17 minus k is 2. So it is equal to what? It is equal to what value? Value you will get. Calculate kore dekhen.
9.39
তো বইতে আছে এটাই আসছে।
জি স্যার 9.3862 আসে।
ওকে, তাহলে ঠিক আছে, ক্যালকুলেশন 9.39. So the result is already compared in earlier case. We know that in the F-test value at the level of corresponding degrees of freedom in the numerator and denominator, we have found that our critical value of the F was, F এর critical value টা কত ছিল? 4.54. So here it was 4.54. So our calculated value is 9.39. So we reject H0. Okay. Is that clear to everyone?
Yes, sir.
Yes sir.
Okay.
Yes, sir.
Now you can see that they also asked you in question number C. আমরা যখন C টা করেছিলাম তখন সেখানে তার একটা কোয়েশ্চেন জিজ্ঞেস করেছিল, একটু যদি দেখেন in number C. In number C I have written down here that F-test actually assesses the joint or overall significance of the regression model. Joint significance or overall significance, which is followed by this explanation. But actually they asked you in the number C that how would you use the F-test to test the preceding hypothesis. Preceding hypothesis টা ছিল individual significance of a slope coefficient. So individual significance of a slope coefficient সেটা ছিল beta B2. So B2 equal to 0 or not equal to 0, or B2 is greater than 0, or B2 is less than or equal to 0, সেটা আমরা টেস্ট করেছিলাম পার্ট বি তে। এটা কি এই একই টেস্টটা কি এফ টেস্ট দিয়ে করা সম্ভব? আসলে এফ টেস্ট will be always used for joint significance or overall significance, and usually remember one thing, that F test will be used to assess the joint significance when there are more than one variable. কারণ জয়েন্ট বা ওভারঅল বলতে আমরা কি বুঝি, যে যখন দুইটা ভেরিয়েবল বা তিনটা ভেরিয়েবল একটা মডেলে থাকবে, when and there are 2 or 3 independent variables included in a model, then the concept of joint or overall significance comes. And in that case, our hypothesis is whether all these explanatory variables are jointly significant on your dependent variable or not. That is our statistical significance hypothesis when we are using the F-test in a regression model or in a multiple regression model when you have more than one explanatory variables. But it is a single regression model. There is only one explanatory variable, and it is unemployment rate. So for a single regression model, there is only one explanatory variable and there is only one slope coefficient. So one slope coefficient when you have, so you can test it, its significance can be tested using the t-test, because t-test is the only test statistic that will assess the individual significance. But joint significance will be always tested by the F-test. So in number C, the explanation I have given, that is okay. But remember one thing, F-test statistic will not be applicable to check individual significance. It will be always applicable to check the overall or joint significance. And overall joint significance will be applicable in that model when you have more than one explanatory or more than one independent variable. Is that clear to everyone?
Yes, sir.
Okay. The last one model, just I am explaining it. It's very simple, polynomial regression model. So in a polynomial regression model, you will just have to take some explanatory variable with a different form for the same explanatory variable, like this, that you have b1 plus b2 x I plus b2 xi square plus b3 into xi square plus b4 into xi cube, and so on. So when you are taking the independent variable in the square form, in the cubic form, or in the complex, many more complex exponent form, and the same variable would have been just given as an independent variable in the separate square form or separate cube form or separate your exponent form in exponent form, then this model is considered as polynomial regression model. It is actually known as polynomial degree models. When you are giving b3xi square, it means a second degree polynomial function. When you are giving b4xi cube, then it is known as cubic or third degree polynomial regression function. When you are giving b5 into xi to the power 4, it is known as fourth degree polynomial regression function. That means same variable x has been inserted in your regression model, once with a square form, with cubic form, with many more complex exponent form. Okay, so this is known as polynomial regression model. This kind of model will be used when you are assessing the movement of your total cost. You know that your total cost consists of two types of cost, fixed cost and variable cost. And fixed cost will be, say here, when your production is zero, still you have this level of cost, which will remain fixed at any level of production you are continuing. So from this level, your total cost will be started. It will be started like this, and then it will be started very high. So that would be the movement of your total cost. And when you are graphically plotting this total cost curve, total line, in that case, your regression model will be followed by like this: y equals to b1 plus b2 x2, sorry, b2 xi, not x2, b2 xi. Xi is the cost or total cost, plus again b3 into xi square. Okay, again b4 into xi to the power xi to the power cube. Okay, it is because in the total cost you have another two cost arises. One is marginal cost. Marginal cost, initially it starts decreasing. At one point of time it reaches at the minimum, and then it starts increasing. Okay, and your average total cost, or ATC, this is your marginal cost, which is the cost of producing one additional unit, and your average total cost, which is the total cost number of quantity. This average total cost has been also moved with the marginal cost, because average total cost depends on the marginal cost, in fact, and it moves with like this. This is your average total cost. Okay, here when you are showing that your y equals to b1 plus b1 plus b2 is found, it is 0.85 xi, minus b3 is found in the minus form, it is found 0.50 xi square. Again b4 is found plus, which is found xi to the power cube. Okay, it is found 0.25 into x to the power cube. Okay. So if it is your estimated regression function, which is followed by a polynomial regression function for showing the total cost of your farm, and you know that your total cost initially it is increasing, and at one point of time it reaches at the minimum, it reaches a point where it remains constant, and after that it starts increasing very high. What is this reason, or why it is actually behaving like this? Behaving like this because in the total cost you have another two cost, which is marginal cost and your, sorry, just let me unmute you all. Okay, so in the total cost, when you are watching that, they have been a trend which is at the very beginning or at the increasing number of output, the total cost is also increasing. At one point of time it remains constant, and after that it will start increasing very high. Why this actually behavior reflected here? Because from the total cost you have watched a marginal cost. Marginal cost, initially it starts decreasing. At one point of time it reaches at the minimum, then again it starts increasing. And average total cost will be also similar behavior reflected, that it starts decreasing at a one point of time, it reaches at the minimum. When it intersects with the marginal cost, it reaches at the minimum, and then it starts also increasing. Okay. So from these two curves, actually there are two findings. One is when MC falls, or when MC actually decreases, average total cost curve or average cost will also falls. When MC is equal to the ATC, or MC is equal to the average total, then ATC is at minimum, or ATC is at minimum level, or remain constant. Okay. And when your MC increases, then your ATC will also increase. So these are the three findings we have from these two graphs from our economic point of view, that when marginal cost falls, average total cost will also falls, and will also be fallen. And when marginal cost is equal to the average total cost, that means when marginal cost intersects with the total cost at this point, then average total cost is at the minimum point, or it will remain as a constant. And when marginal cost increases, average total cost will also increase. You can see that when it is in the increasing trend, average total cost is also in the increasing trend. So why is this actually happening? Because as I told you in the earlier case with one of your queries, that when you're starting the production, if you increase the level of your production, then marginal cost will be fallen because of the economies of scale, because of the diminishing marginal return, because of the diminishing marginal utility or marginal return. So that is why it starts to be fallen. At one point of time, it reaches the minimum, and then when the full production capacity has been used, all of your production capacity has been fully utilized, all of your labors have been efficient, all of your raw materials have been utilized, none of them will be wasted. In that case, your marginal cost would be at minimum point. But after that, it will start increasing, because in that case, because of the continuous working, your levers, sometimes there will be some situation happen or circumstance happen that your levers will remain idle, your machineries will remain idle, because full production is going on, and at one point of time, your marginal cost has remained at the minimum level. And after that, when it starts increasing, the increasing point will be started when there is a diminishing return of the marginal utility found. Diminishing return of the marginal utility found in that point, when there are some labors will remain idle, because maybe you have 15 machineries and you have 20 labors, so 5 of them will remain idle, because all of the machineries are continuously operated by only one labor will be required to operate each of the machinery. So when 15 machineries are fully operated, only 15 levers will be used here. Other 5 levers will remain idle. And because of these idle resources, marginal cost will start increasing. And here is the reason for which you are actually using the polynomial regression function to show your movement of the total cost curve. And you can see that when your marginal cost starts increasing, and at one point of time it intersects with the average total cost, and after that both of them are increasing, this is the position which is reflected in the high increase of the total cost. And this is the position when the total cost remain very stable or constant, when your marginal cost is at the minimum point. Okay, when your marginal cost is at the minimum point, this is the point when your total cost will remain constant for a longer period, or for a longer time. Now you can ask me why there is some minus or there is some plus slope coefficient found. Minus slope coefficient found because X is here total cost. Here X is total cost, and your X is the total output, and Y is total cost. So it means for the first coefficient, it is found positive. So the more output you are increasing, the more cost you will have. For the second coefficient, it is found negative. It is found negative because if you increase the production level, your cost will be increases, but it will be increases at a decreasing rate. I repeat, when you have found that the second coefficient value minus 0.50, this second coefficient value is found minus 0.50, it means when you are increasing your level of production, your total cost is increasing. That is good. You can see that your total cost is increasing, but the level of increase or the rate of increase is a decreasing trend. Is that clear to you? Why there is a minus sign in front of the
Yes, sir.
0.50?
Yes, sir, clear.
Okay. তার মানে হচ্ছে আমার প্রোডাকশন বাড়াচ্ছি, কস্টও বাড়ছে। ঠিক আছে, কস্ট বাড়ছে, that is good. That is understood by my first point of slope coefficient B1 equal to 0.85. But এই যে কস্টটা বাড়ছে, this cost has been increasing at a decreasing rate. And that is why there is a minus sign found in front of the second coefficient B2, which is found minus 0.50. Okay, so that is why there is a minus value found. এটা আপনি এভাবেও দেখতে পারেন যে if you just take the differentiation of this y, say b1 plus 0.85x আর এখানে হচ্ছে minus 0.50x square, এই তো ওই কিউবটা এখন আর আনলাম না, just I am differentiating this. So when you are differentiating this b1 plus 0.85x minus 0.50x square, so you can see that constants differentiation d by x b1, constants differentiation is always 0. D by dx for 0.855x and d by dx for d by dx, there is a minus sign, d by dx 0.50x square, ito. So its differentiation is 0, its differentiation is 0.85 minus, there is a square, it will come in front of this, so 0.50 into x to the power 2 minus 1. In actually 0.85, 85 because x to the power 1 minus 1, so x to the power 0, so you have actually 2 into 0.5 into x. So you can see that the slope coefficient is here 2, which is negative, and it means now if you increase the level of output, your cost will be decreased. Which cost actually decreased? Your total cost is increasing, but the rate of increasing it as at a decreasing rate. Rate of increasing of your cost is at a decreasing rate. So that is why there is a minus sign found in front of the coefficient here in your estimated regression model. Okay, I think it's clear to everyone why there is a minus sign in front of the slope coefficient value. I think we have done all the regression models. Okay. Oh, I will take another 5 minutes for you. The last one, number 6, is regression through the origin. Regression through the origin, here actually there is no intercept term. Regression through the origin means it will be started from the 0 of your graph. That means there will be no intercept, no intercept coefficient in the model, like it would be only b2 xi plus your ei. This is your SRF, stochastic SRF. So you do not have any b1 here. Or if you just go through the population regression function, it will be beta 2 xi plus ey. This is your PRF, while there is no intercept. So regression through the origin, when it is using, we will estimate the value of B2, which is the proxy of the beta 2. How can we estimate the value of B2? We'll estimate their value using their using their raw sums. Raw sums means you'll have to use the capital X and capital Y, not the small x, not the small y. In our earlier calculation of our of the estimated values of the parameters in your regression model B2 and B1, we have used the small x, small y. Here we will use capital X, capital Y divided by capital X square. That is how we will estimate the value of B2 here. And when we are estimating the standard deviation of the B2, that means sigma of the B2, then the error variance, which is followed by sigma EI square divided by your sum of capital X square. This error variance, which is estimated based on your sample, it is equal to the sum of EI square divided by n minus 1. Now, can you please tell me why there is n minus 1 in the denominator? We know that from our earlier two variable model, when we are calculating this sigma square head square, which is the error variance.
We have only one parameter, sir.
N minus 2. Sorry?
We have only one parameter.
Exactly. We have only one parameter, which is the slope coefficient. There is no intercept. Okay, that is the reason. So now the question is, when we will use this kind of model, or in which segment or in which economic theory we will use this kind of model, regression through the origin. We will use it in regression through the origin. We will use it in the total revenue curve. You know that your total revenue will be started from 0 level of quantity. If X is your level of output, if you are producing no output, what you are going to sell? So if you're producing no output, there will be no total revenue you will generate. If you increase your production level, then and only then your total revenue will be increased, isn't it? So in that case, those kind of, when Y is your total revenue, for those kind of model, you can use B2 Xi. Xi is your, B2 is your slope coefficient. Slope coefficient means from this point to that point of the total revenue, what is the distance? That will be measured by B2. Is that clear to everyone?
Yes, sir.
So in the y-axis, you are showing the total revenue. In the x-axis, you are showing the output level. Is that clear to everyone or not? এখানে এই ধরনের মডেল যখন ইউজ করবেন, when you are using the regression through the origin model, যেটা শুরু হবে 0 থেকে একদম from the very beginning, সেই ক্ষেত্রে কয়েকটা ডিফারেন্স আছে। একটা ডিফারেন্স, এটা বুঝতে পারছেন অলরেডি ডিফারেন্সটা কি হবে, যে usually when we are comparing between two models, we will use R square value, or when we are actually using the R square value, this is actually used to know the explained sum of a square. So a R square which has been used in our two variable model or three variable model where there is an intercept term. So R square value calculated considering the intercept term. But here in this model, there is no intercept. So do not use R square value here. Okay, do not use R square value here in this regression through the origin model to assess the overall significance or to assess the explained sum of a square of your model. Amra R square দিয়ে কি assess করি যে dependent variable how much variation has been done or how much variation has been caused by the independent variable, or how much variation has been explained by the independent variable. So these should be applicable when we are using the, or we are calculating the R square for a model that have an intercept term. But here in this model, it is without intercept term, so we cannot use the R square to make the explanation of the variation in the dependent variable here because of the changes of independent variable. আরেকটা হতে পারে যে অনেক সময় for this regression through the origin model, we know that as per the classical linear regression model, our summation of the error term would be always equal to 0 or approximately equal to 0. It is approximately equal to 0. In here, regression through the origin model, it may not be equal to 0. পেতে পারেন এরকম, এই ধরনের ডিফারেন্স গুলো হতে পারে, এটা বলা আছে আর কি। Okay, is that clear to everyone?
Yes, sir.
Yes, sir.
So there are two assumptions will not be effective here. One is R square value cannot be used in the regression through the origin model. Another one is sum of EI or summation of the error term will not be equal to 0 sometimes. If it is okay, I am giving you two problems to solve by yourself. দুইটা প্রবলেম একটা হচ্ছে পেজ নাম্বার, সেটা আবার নতুন পুরাতন পেজ নাম্বার। In the third edition, it is page number 513, এটা গেল কোথায় এখানে, 913, page number 282. Problem number 9.14. আমরা বোধহয় 9.13 টা করেছি, তাই না?
Yes, sir.
9.14 পরেরটাই আপনারা করবেন। এটা একটু বলে দিই কিভাবে করবেন, মানে আমি জাস্ট মুখে বলছি শুনেন, এটা স্ট্যাটা সফটওয়্যারটা ইউজ করবেন। এখানে যে র ডাটাটা দেওয়া আছে, ইফ ইউ আর জাস্ট গোয়িং টু ক্যালকুলেট দ্য প্যারামিটারস ভ্যালু ফর ইচ মডেল, B1 B2 এর ভ্যালু যদি আপনি ক্যালকুলেট করতে যান, and if you want to do that manually, it would very much cumbersome for you, অনেক পৃষ্ঠার পর পৃষ্ঠা লেগে যাবে। So আমি রিকমেন্ড করব you use the stata software, input this data and it will automatically calculate your output of the regression. ওকে, এখানে চারটা রিগ্রেশন মডেল আপনাকে এস্টিমেট করতে বলেছে। ইফ ইউ জাস্ট লুক এট দ্য নেক্সট পেজ, রিগ্রেস y on x, মানে এটা হচ্ছে অনলি সিম্পল লিনিয়ার মডেল। নাম্বার 2 হচ্ছে lny on lnx, that means it is log linear model. Number 3 is lny on x, semi-log model. Number 4 is y on lnx, তার মানে হচ্ছে এটা কোন মডেল? Lin log model. So there are 4 models you have been asked to estimate. একটা হচ্ছে সিম্পল লিনিয়ার মডেল, নাম্বার বি হচ্ছে আপনার লগ লিনিয়ার মডেল, নাম্বার সি ইজ সেমি লগ মডেল, ইয়েস, নাম্বার টি
Lean log model.
ইজ লিন লগ মডেল। ঠিক আছে, এটা সফটওয়্যার ইউজ করে ক্যালকুলেট করবেন, দেন জাস্ট ইন্টারপ্রেট দ্য estimated coefficient and there are some other requirements are also given. Number C te bola ache bodhoy, for each model find the rate of change of y with respect to x. Just হচ্ছে এটা আপনি স্লোপ কোএফিসিয়েন্টটাকে এক্সপ্লেইন করবেন, ফাইন্ড দ্য মানে স্লোপ কোএফিসিয়েন্টের ভ্যালুটা লিখবেন যে ফাইন্ড দ্য রেট অফ চেঞ্জ অফ y with respect to x has been given only from the slope coefficient, তো সেটা আপনি এখানে লিখবেন। নাম্বার ডি তে বলা আছে যে for each model find the elasticity of the y with respect to x. For some of this model, the elasticity is to be computed at the mean values of y and x. মনে রাখবেন এখানে একটা মডেল আছে শুধুমাত্র যেটার ইলাস্টিসিটি মিন ভ্যালু থেকে ক্যালকুলেট হবে না। কোনটা একটু বলেন তো? সেকেন্ড ওয়ান, log linear model. For the log linear model, elasticity is already given. Log linear
Yes,
model
sir.
কে দুই
E2.
পাশেই তো log নেওয়া হচ্ছে, তাই না? ln y তেও আছে, আবার ln x ও আছে, এটাকে তো আমরা log linear বলছি। So in the log linear model, it is already, the slope coefficient is already calculated or estimated in terms of elasticity. So এখানে নতুন করে elasticity calculate করতে হবে না, it's already given. But for linear form, semi-log form and from lin log form, আমি তো এই তিনটা মডেলের elasticity calculate করার ফরম্যাট দিয়ে দিয়েছি আপনাদের। So using that format, you can calculate the elasticity both for linear, semi-log and lin log model. বুঝতে পেরেছেন?
Yes, sir.
Okay.
আরেকটা হচ্ছে based on all these regression results, which model would you choose and why? বলেন এটা কিভাবে করবেন? স্টেপ বলেছিলাম না?
Yes, sir.
Yes, sir.
Last class
Step.
এ?
Yes, sir.
There are steps I have mentioned. Okay. That steps were applicable between linear and log linear model. When you are given these two models, linear and log linear models, you can choose any one of them considering those steps. But এখানে দেখেন, when you are choosing the model based on r square, remember that the dependent variable should be in the same form. তাহলে এখানে কিন্তু r square value বের হবে আপনার আউটপুট থেকে, you will get the r square value. So between considering this r square value, it would be applied for two models to compare which one is better. একটা হচ্ছে আপনার log linear model এটার জন্য, আরেকটা হচ্ছে semi log model। কেন বলেন তো? Because both of these two models dependent variable is in ln y form, log form এ আছে দুইটাই। Clear? আর আবার r square will be also applicable to choose another one model between two model, which is one is linear model মানে a তে যেটা আছে, another one is d তে যেটা আছে lin log model। কেন বলেন তো? Because both of these
Dependent.
two models, dependent variable are in the absolute form of, so they are in the y only. বুঝতে পারছেন? না বুঝলে কিন্তু জিজ্ঞেস
Yes,
করেন,
sir.
আদারওয়াইজ পরে বলবেন যে আমি এক্সপ্লেন করছি না। আর স্কোয়ার দিয়ে প্রথমে আপনি চারটা মডেল, তো আপনাকে কাজটা শর্ট করে দিচ্ছি আমি, ইউ উইল গেট দ্য আর স্কোয়ার ভ্যালু ফর অল অফ দিস 4 মডেলস। সো ফার্স্ট আপনি যে কাজটা করবেন, compare R square value between log linear model and semi-log model, because both of these two models dependent variable, দুইটারই dependent variable সেটা হচ্ছে ln y ফর্মে আছে। তার মানে আপনি যদি when both of the dependent variable are in the same form, you can compare between them using the R square value, যেটা R square value বেশি সেটাকে প্রেফার করবেন। Similarly, R square value will be also applicable for those two models when both of your dependent variable absolute form, যে একটা হচ্ছে in the part A, you are estimating the linear form of regression model. In part D, you are estimating the lean log model. Lean log model কি হয়? Dependent variable in the linear, dependent variable is in the absolute form. এবং linear form, only linear যেটা সেখানেও dependent variable is in the absolute form. আমার কথাটা বুঝতে পারছেন? So we can compare between these two model using the R square value. তারপরে দেখেন এখান থেকে একটা মডেল বের হবে ভালো, এখান থেকে আরেকটা মডেল বের হবে ভালো, ঠিক আছে? Now you can choose between these two models, not based on the R square, but based on those steps I have explained in the earlier class. একটু ক্লিয়ার কিনা দেখেন।
Yes, sir.
Yes, sir.
আরেকটা করবেন, সেখানে এক্সপ্লেন করার কিছু নাই, ওটা করে দেওয়াই আছে, শুধু আপনারা ইন্টারপ্রেট করবেন। 9.17 এটাও আপনারা করবেন, ঠিক আছে?
Yes, sir.
Okay, then that's all for today. I'm taking your attendance. Attendance time to কমে গেছে। So now you can unmute your microphone. First, response from the banking stream. Roll number 2.
Present, sir.
So you're not present in the earlier class, okay?
Yes,
Roll number
sir.
3.
Present, sir.
5.
Present, sir.
6.
Present, sir.
7.
Yes, sir.
8.
Yes, sir.
9.
Present.
Number 9. 10.
Yes, sir.
11.
Present, sir.
13.
Present, sir.
14.
Yes, sir.
15.
Yes, sir.
16.
Yes, sir.
17.
Present, sir.
19.
Present, sir.
22.
Yes, sir. 21. Present,
21. 22 আছেন, হ্যাঁ। 24.
Yes, sir.
26.
স্যার উঠছিল প্রবলেম দেখাচ্ছে।
উপরে সবাই প্রেজেন্ট আছে আজকে, অসুবিধা নেই। 29. 29. 30.
Sir.
Sir, 30 present ছিল।
হ্যাঁ, 31.
Yes, sir.
33. 34.
Yes, sir.
37.
Sir, 36 call করা হয় না।
36, হ্যাঁ দিয়েছি। 37.
ছিল স্যার।
Okay. 39.
Yes, sir.
41.
Yes, sir.
42. 44.
Yes, sir.
46.
46 sir present ছিল।
47.
Present, sir.
সবাইকে দিচ্ছি। 47.
Present, sir.
48.
Present, sir.
49.
Yes, sir.
50.
Yes, sir.
51.
Yes, sir.
52.
Yes, sir.
53.
স্যার শেষ মোবাইল আসছে
54, 55, 56,
Present, sir.
57,
Yes, sir.
58,
Yes, sir.
62, 62 আছেন? 63,
Yes.
64, 65,
Present, sir.
69,
Sir, 69 sure, sir.
71, DHC,
Yes, sir. 71.
74, 25,
Present, sir. 75 present, sir.
okay, 76,
yes sir
77,
Yes, sir.
80, okay, 81,
Yes, sir.
82, 84,
Yes, sir.
85,
Present, sir.
87,
Yes, sir. Sir, 87.
okay, 88,
Sir, 87.
হ্যাঁ দিয়েছি 88 আছেন?
Yes, sir.
91,
Yes, sir.
92,
92, sir.
92 আছেন, okay, 93,
Yes, sir.
94,
Yes, sir.
95,
Yes, sir.
96,
Yes, sir.
99,
yes sir
101,
Present, sir.
2,
yes sir
104,
yes sir
8,
yes sir 8 ছিল স্যার
109,
yes sir আমি লাস্ট ক্লাসে ছিলাম স্যার
111, okay, 111, 12, 111
Yes, sir.
আছেন? 12 is present, 113,
Yes, sir.
11 present ছিল।
okay, 114, 9, 115,
Sir, present ছিল নেটে প্রবলেম।
okay, 117,
yes sir
22,
Yes, sir.
123, 128,
তো 23 present ছিল।
ঠিক আছে দিয়েছি,
20 disconnect.
129 আছেন?
Yes, sir. 29.
Okay, 131,
Yes, sir.
132,
Yes, sir.
133,
yes sir
38,
Yes,
130,
sir.
okay, 149,
sir
150,
Yes, sir.
2,
Yes, sir.
173,
yes sir
175,
Yes, sir.
177, 178,
Yes, sir.
179,
Yes, sir.
182, 183,
Yes, sir.
182 আছেন? Anyone left from the banking stream?
Yes, sir.
Okay, then insurance stream, banking stream, you can leave. See you in the next class, Tuesday at 3 p.m. So insurance stream, response please.
Sir, roll 37.
হ্যাঁ দিয়েছি, রোল কত? রোল বলেন কত, বুঝি নেই আমি। 38, anyway, okay, insurance stream, roll number 4,
yes sir
20,
Yes, sir.
25,
yes sir
32,
Yes, sir.
38,
Yes, sir.
43,
37
Yes, sir.
last master.
59,
Yes, sir.
60, Roll number 60. Roll number 67. 97.
Yes, sir.
Roll number 100. 100. 103.
Yes, sir.
106. 110.
Yes, sir.
16.
Yes, sir.
18. 118. Roll number 124.
Yes, sir. Sir, গত ক্লাসে প্রেজেন্ট ছিলাম স্যার।
Okay, roll number 127. 30. 130. Roll number 139.
Sir, 135 আছে।
5 আছে।
Sir, 139 present, sir.
140.
135 গত ক্লাসে ছিলাম।
Okay. 140 আছেন? 9. 141. 141. 144.
Yes, sir.
171. 171. 174. 174.
Yes, sir.
176. 176.
Yes, sir.
180.
Yes, sir.
Yes, sir.
181. 181. 184.
Yes, sir. Sir, 184.
186. 190. 192.
Yes, sir.
193.
Yes, sir.
195. 197. 195 আছেন? 197 আছেন? 198. 270.
Yes, sir.
271.
Yes, sir.
361.
Yes, sir. Sir, আমি গত ক্লাসে ছিলাম।
Okay. 363. 363. 364.
Yes, sir.
301. 401. 401. 81 from 21st.
Present, sir.
97 from 21st.
Present, sir.
27 from 21st.
Sir, 401.
401 দিয়েছি। 27 from 21st
বাইরে তো লাগাও না।
Sir, 363 message দিচ্ছে।
লক করো।
Okay, 363
কেমনটা লাগে রে?
দিয়েছি। Anyone left?
67 আওয়াজ শোনা যাচ্ছে না। ও বলছে 67 present, sir.
60.
67, sir. ওর অডিওতে মনে সমস্যা।
67. Okay, দিয়েছি present. Okay, then anyone left? So thank you. See you in the next class, Tuesday at 3 p.m.
প্রশ্ন ছিল স্যার একটা।
বলেন।
স্যার আমাদের 10 নম্বর ক্লাসের যে লেকচারটা দিয়েছেন ড্রাইভে ওটা বলতে স্যার অ্যাক্সেস চাচ্ছে না এগুলো।
অ্যাক্সেস পাচ্ছেন না ভিডিওতে?
না স্যার।
ঠিক আছে, দেখছি।
আচ্ছা স্যার। আসসালামু আলাইকুম।
ওকে। ওয়ালাইকুম সালাম।
থ্যাংক ইউ স্যার। আসসালামু আলাইকুম।
হ্যাঁ, ওয়ালাইকুম সালাম, ভালো থাকেন।